All right, we're going to do one more system of 3 by 3 equations. Once again, we are using the elimination method here. So we are going to take two of the equations we are given and eliminate one of the variables. The variable I'm choosing to eliminate this time is my x. Like I told you before, you can eliminate whatever variable you'd like to do. So, I think the one I chose to do, let me just look right here. It's the end of the day. Let's take our first and our second equations. Looking at my first and my second, if I'm choosing to eliminate x, I have a 2x and a negative x. I need to multiply my second equation by 2 so I can easily eliminate my x. So I have 1 in the second equation, but I'm multiplying the second equation all by 2. So 1 is staying the same, 2x plus y minus 3z equals 11. And the second one, I'm multiplying everything by 2. So negative x becomes negative 2x. Plus 2y becomes plus 4y, plus 4z becomes plus 8z, and negative 3 becomes negative 6. All right, so now I'm going to eliminate my x by adding my equations. So I now have 5y plus 5z, and that is going to equal 5. The next one I'm going to look at, I'm choosing to look at my second and my third. This is going to be easy for me to eliminate because negative x and a positive x will quickly add and eliminate together. So I take these two. Actually, let me just write these two next to each other. So if I'm taking these two and I add them, negative x plus x, that'll go away. 2y minus 5y, because I'm really adding negative 5, is going to be negative 3y. 4z plus 2z will be 6z. And negative 3 plus negative 18, that'll give me negative 21. So now I'm just going to move it over here so it's easier for me to deal with these two systems together. All right, so now it's just like what we did before. I'm dealing with a system of 2 by 2s. So the easiest thing for me to do, I like to do, is elimination. So I'm going to multiply the top equation by 3 and the bottom equation by 5. The reason I'm doing that is I'm just going to eliminate the y. It just is an x letter. I felt like it. One's a 5y and one's a negative 3y. The one where there's a 3, that's why I'm multiplying everything by 5. Where there's a 5, I'm multiplying everything by 3. So now this is going to become the equations 15y plus 15z equals 15 on the top. And the second one, we'll have negative 15y. Remember, that's why I wanted to cancel these two out. 5 times 6 is going to be plus 30z. And that's going to be equal to 5 times negative 21. All right, well, 5 times negative 21, that's going to give me negative 105. Okay, hopefully my math was correct on that one, folks. And now I can add these together because, once again, the y's will eliminate. All right, so 15z plus 30z will become 45z. And 15 plus negative 105, that'll become negative 90. I'm going to divide both sides by 45, and I get that z is equal to negative 2. But I'm not done yet. I need to take my value for z and plug it into one of my smaller 2 by 2 systems to find my y value. I like this first one. 5y plus 5z equals 5. So we have 5y plus 5 times my z value, negative 2, is equal to 5. 5y minus 10 equals 5. I'm going to add 10 onto both sides. So we get 5y is equal to 15. Divide both sides by 5, and we get y is equal to 3. The last thing I need to do is take my z and my y value and plug it in to solve for x. Let's return to the black marker. And I need to plug it back into my original equation. So let's take, let's do the first one. Why not? 2x plus my y value of 3 minus 3 times my z value of negative 2 equals 11. So we have 2x plus 3. Negative 3 times negative 2 is going to be plus 6. Is 11. So we have 2x plus 9 equals 11. So we have 2x equals, we're going to subtract 9 from both sides. 2x equals 2. Therefore, when I divide both sides by 2, x is equal to 1. Therefore, my solution in alphabetical order, 1, 3, negative 2. Once again, I would recommend that you go back and check your answers because mine might not be right, but they actually are. So, good luck.